Hi everyone, we're going to go over the types of problems that we started to talk about on Friday, and then class just got a little messy, so we're going to spend some time going over it now. So this is a video to help you if you're still struggling. And so I want to point out that we're going to go over problems that look similar to what we've been doing. There's just something slightly different about them. So we can see here that there's no longer theta but an x, and that our bounds have changed. So we're still going to think about this idea of how do we solve for theta, but our final answer isn't going to be that theta that we find, it's going to be x. So I want us to think about how we can take our expression and think about it how we can take theta and substitute it in for 5 over 6x. So I could kind of rewrite my equation, bear with me, to say something like 2 times sine of theta plus 1 equals 0. And I forgot to do plus 1. Plus 1 equals 0. And then we'll eventually solve for x. So you can think about this exactly like the expressions and equations we've done before. So we're going to solve for theta in the same way we've done in the past. So we subtract 1 from each side, and we get sine, and I'll keep putting theta here because we know this isn't really the equation, right? It really isn't the true expression. It's what we substituted in for 5x over 6 equals negative 1. And then we can divide by 2 on each side, and we're left with sine of theta equals negative 1/2. So we can think about this similar to how we've always been thinking about these problems, is when does theta equal negative 1/2? So when we substitute in theta into sine, when do we get an output of negative 1/2? And if you look at your charts, we can see that this happens when theta is 7 pi over 6 and when theta is 11 pi over 6. And you can think about it in regards to how delta math does, where it says sine is going to be negative in quadrants 3 and 4, and the reference angle when sine equals 1/2 is pi over 6. So in quadrants 3 and 4, pi over 6 is 7 pi over 6 and 11 pi over 6. So you can think about it, right? We can just like use this idea of substitution again, bear with me, and we can say, right, that sine of 7 pi over 6 equals negative 1/2. And we know this is true. And we can say that sine of 11 pi over 6 is equal to negative 1/2. And we can see that these equations hold true. But I want to bring us back to this idea that we're not really solving for theta. We're solving for this idea and this expression here that we have out, that theta is equal to 5/6x. So we need to now set up like two equations to solve for x. So we know that when you substitute in 7 pi over 6 into sine, you get negative 1/2, and 11 pi over 6, and you get negative 1/2. But we want to see what value of x does this give us. So what value, right? So 5 over 6x times what will give us 7 pi over 6. And 5/6x times what will give us 11 pi over 6. And here we're just going to want to simply solve for x. So we can divide by 5/6 on each side, and we're left with x equals 7 pi over 6. And when you divide by a fraction, it's like multiplying by its reciprocal. And when we do this, the 6's cancel out, and we're left with x equals 7 pi over 5. And this would be one of our final answers. And we can do the same thing on our other equation where we divide by 5/6 on both sides. And remember, it's like multiplying by the reciprocal. So we get 11 pi over 6, and it's like multiplying it by 6 over 5. The 6's cancel out, and we're left with x equals 11 pi over 5. And I'm not sure about you, but these answers feel a little wonky to me because they're not theta, right? Those reference angles that we've been dealing with. So I want us to think about how if I take my simplified equation that we had, and we take the same equation we had before, right? Sine of 5 over 6x equals negative 1/2, right? Because that's really what that theta was if we're substituting it back in, right? If we think about, here I can start so you can see it again. If we think about sine of theta equals negative 1/2, we're just plugging in theta, right? Or that theta equals 5, 6x here and here. So we just substituted it in for theta based on this equation that we had up here. And if we plug in x into these equations, we're left with sine of 5, 6 times 7 pi over 5 equals negative 1/2. And when I simplify this down, we can see that the 5's cancel each other out, and we're left with sine, are you ready for this, of 7 pi over 6 equals negative 1/2, which is the same exact equation that we had here. So it's just finding the x values, have those equations be equivalent to each other. And we can do the same thing here. Sine of 5 6 times 11 pi over 5 equals negative 1/2. And when we simplify, again, we're going to be left, the 5's cancel each other out, with the same expression we had seen earlier in the video, right? 11 pi over 6 equals negative 1/2. And it's the same exact expression that we see here. And that's how you solve these problems. So I know we went over this quickly at the end of class, but in case you needed a refresher or a more clarifying video, hopefully this helps. We'll do one more type of problem where the coefficient is actually a pi value. So if we, let me make it a little bigger. Okay, so if we see here now, our expression is similar, but it's actually pi times x instead of a fraction. And we can see here now that our bounds no longer include pi. So what does this look like as we're solving? So we can take 2 sine of pi x minus the square root of 2 equals 0. And what I could do in this equation is that we're going to solve, again, with this concept of theta, right? So I can take this part of the expression and have theta equal pi times x, and I can rewrite my equation to say 2 times sine of theta minus the square root of 2 equals 0. And then I can solve my equation. So plus the square root of 2 on each side, and we're left with 2 times the sine of theta equals the square root of 2. And then we can divide by 2 on each side, and we can get sine of theta equals the square root of 2 over 2. And for what values of theta, when you substitute them into sine, do we get the square root of 2 over 2? And this happens with reference angles of pi over 4. And we know that sine is positive in quadrants 1 and 2. So we can also use your chart to see when does theta equal the square root of 2 over 2 when substituted into sine. And we get values of pi over 4 and 3 pi over 4. And again, if you substitute them into that equation, I'm going to skip this step since we did it, but sine of pi over 4 equals the square root of 2 over 2, and sine of 3 pi over 4 equals the square root of 2 over 2. So now what we're going to want to do is we're going to want to take this value for theta, right, this idea that theta equals pi times x, and we want to solve for x. So I could take my expressions and say that pi over 4, right, is equal to pi times x, and that 3 pi over 4 is equal to pi times x. And then we just want to solve. So I would divide by pi on both sides, and this is like the equivalent of saying x, because the pi's cancel out, is equal to pi over 4 times 1 over pi. And when we do this, the pi's cancel out, and x is equal to 1/4. So we can see here now that our x value does not include pi, since pi is the coefficient in that expression. And we'll substitute that in a little bit to see how that works. We can also divide each side by pi here, and we're left with x equals 3 pi over 4 times, and the reciprocal of pi is 1 over pi, and this leaves us with x equals 3 over 4. And if I come back to that original expression, right, but instead of having theta, I leave my value as sine of, hang on, let me write it so it's easier to understand with colors. We leave it as sine of pi x, right, equals the square root of 2 over 2. I can substitute this in for both equations. So we're going to substitute x in to see if we get those values. And let's see what happens because of that pi. So we're left with sine of pi times 1 over 4 equals the square root of 2 over 2. And we're left with sine of pi times 3/4 equals the square root of 2 over 2. And when we simplify this part of our expression here, we're left with sine of pi over 4 equals the square root of 2 over 2. And we're left on this side with sine of 3 pi over 4 equals the square root of 2 over 2. And we can see that these are the two equations that we had, or the two values of theta that we had found here and here. And so hopefully this helps. We'll continue to review in class, but this is the last big piece of information. You will have an exam toward the end of this week that either happens in class on Friday or over the weekend, depending on your choice. And I will answer any questions you have, so you're more than welcome to send emails or anything like that.